we can show that the derivative of the other remaining trig functions are some given value. On your formula sheet, number 13 and 14 are the derivatives of sine and cosine. Today I'd like to show you how we could use quotient rule to get the other four derivatives for the remaining trig functions. Derivative of tangent is secant squared. The derivative of tangent x is secant squared x. We'll prove that here in a second with quotient rule. Derivative of cotangent x is negative cosecant squared x. See here. Derivative of secant and cosecant. Derivative of secant x is secant x times tangent x. Derivative of cosecant x is negative cosecant x cotangent. I'll look at a couple of these, but the proofs are pretty basic. Once you do one, you can kind of see how the rest might go. Let's find the formula for the derivative of tangent x. It's going to be secant squared x, but let's use quotient rule to get that. Quotient rule is for the derivative of a function written as something divided by something. So tangent x is what divided by what? Sine of cosine. So I'm going to write tangent as a quotient. Sine x over cosine x. And let's apply quotient rule to that function. So low d high, f prime of x would be cosine x times the derivative of sine x, which is another cosine x, minus the high, sine x, times the derivative of cosine x. What's the derivative of cosine? So you can count. Negative sine x. All divided by cosine squared x. I'm applying the quotient rule process to tangent after I changed it to sine x over cosine x, in order to see where the derivative of tangent x is going to come from. What is cosine x times cosine x? Cosine times cosine would be cosine squared x. Negative sine x times negative sine x would be positive sine squared x. If you have your formula sheet out, flip over to the page that has all those trig identities on it. What is sine squared x plus cosine squared x equal to? 1. Sine squared plus cosine squared is always going to be 1. Sine squared plus cosine squared, I could use a trig identity for. That's a Pythagorean identity for 1. One over cosine squared. What's 1 over cosine? 1 over cosine x is secant. If 1 over cosine x is secant, 1 over cosine squared x would be secant squared. By applying quotient rule, the derivative of tangent x is secant squared x. The proof for cotangent x is pretty similar. But do you see how it's a little bit different? The derivative of cotangent x is the opposite cofunction. So cotangent is negative cosecant squared. Just like the derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. Let's try one more. Let's do the derivative. Let's just do secant. Secant x. We're going to use quotient rule to see where the formula for the derivative of secant x comes from. It should be secant x tangent x. On your trig identity page, secant x is what divided by what? 1 over cosine, yes. So 1 divided by cosine x. And we're going to apply quotient rule to that formula. So I'm singing that out loud to myself. Low, be high. What's the derivative of 1? Derivative of 1 has to be 0. Minus the high times d low all over low squared, cosine x squared, cosine squared x. Cosine times 0 is going to be nothing. Negative sine x times negative 1 should be positive sine x.
Kinsey Shaver, please report to the secondary office. Kinsey Shaver, report to the secondary office.
Cosine squared is cosine x times cosine x. So I'm going to write that as 1 over cosine x times sine x over cosine x. I'm going to split apart this quotient. Instead of sine x over cosine squared is 2 cosine being multiplied together. So 1 over cosine times sine over cosine. 1 over cosine x, identity form. 1 over cosine is the same thing as secant. Sine over cosine would be tangent. Derivative of secant x is secant x times tangent x. Similarly, the derivative of cosecant x would be negative cosecant cotangent. And now we have the comprehensive list, the derivative of all 6 trig functions. Using these 2 basic trig derivatives plus quotient rule, I can get the other remaining 4. All right, could you guys grab your laptops? I'm going to pull up some practice. I'll let you guys try a few here after we do a couple together. Let's see, S7, you 2 S7. We just try the first couple together here. I'm going to skip down to number 42 because on 42 through 53, this will be the section on derivatives of all the 6 trig functions. Derivatives involving all 6 trig functions: sine, cosine, tangent, secant, cosecant, cotangent. I'm going to skip around. Anyone got a problem with that? I just kind of pick a couple that I think would be good to do. Okay. Let's try 43. Let's real basic one. X plus cotangent x. What's the derivative of x plus cotangent x? Term by term, what's the derivative of x? Well, I have a formula for the derivative of cotangent x. Negative cosecant squared x. Pretty basic to me. Done. Skip down, let's try 45. 1 over x minus 12 secant x. This is good practice on other basic differentiation rules too, because I'm using those basic rules in conjunction with the derivatives of the other 6 trig functions. Okay, term by term, what's the derivative of 1 over x? How could I rewrite 1 over x so that I could take the derivative in the first place? Write it as x to some power, perhaps. Why negative exponent, Shay? Right, so if I want to bring that up on top and write it as x to a power, I need to use negative exponent. Now that I have it written as x to the negative first, I could use power rule to take the derivative. What do I do with the negative 1? It's negative 1 times x to what new exponent? Bring down the negative 1, it gets new exponent using power rule is just 1 less than what was there before. What is the derivative of 12 secant x? Secant x would be secant x times tangent x. You just take that derivative times the other 12. So minus 12 times secant x and tangent x. One last thing to simplify. I want to kind of see where I'm going to go to get this written in its final form. By putting it
in the denominator.
So negative 1 times x to the negative second is really what? Right. I'm moving the negative exponent, not the negative sign. Some people always get that kind of confused. What is kind of stopping me from having my final answer? It's the negative exponent, not the negative. Negative 1 over x squared minus 12 secant tangent. About 50. F of x equals x squared times tangent x. X squared tangent x. How do we take the derivative of x squared tangent x? I'll tell you, it's not just the derivative of x squared times the derivative of tangent x. What rule would I have to use to find that derivative? Product rule, what? What are my two functions that are being multiplied together? So here's the first function. Here's the second. What is product rule if you kind of say that to yourself? We have a rule to say the quotient rule. What's the rule to say the product rule?
First times derivative of the second
Plus,
second times derivative of the first.
there we go. First times derivative of the second plus the second times the derivative of the first.
So why didn't we do that though when it was 12?
Because this is a constant times a function. If it was 12x times secant x, now it's a function times a function. If you want to do product rule for this, Shay, you can. It's just going to be a little bit longer to get to your final answer. It still works. I just wouldn't do it like that. On your formula sheet, what I'm kind of thinking of here is number 1. The derivative of a constant times some function is that constant times the derivative of the given function. If you still want to use product rule, go ahead. It's just going to be a little bit more work to get you there. You're not wrong. It's just maybe not the most efficient. So first times the derivative of the second. What is the derivative of tangent? Square x plus the second times the derivative of the first. X squared derivative, the x squared derivative would be what? X. Oh, I can't spit out the word derivative. Talk really fast. F prime of x would be x squared secant squared x
plus 2x times tangent.
All right, we got about 15, 20 minutes left. I'd like you to get down through 53. We'll do derivatives of logs tomorrow, derivatives of natural logarithms tomorrow, and then come back next week and take that quiz like I talked about on the first half of Standard 7, as well as going back to look at Standard 6 on graphs of derivatives. I didn't want to throw too much at you and wait too long to take our next assessment, so I'll cut S7 in half, since we still have other basic differentiation rules to go through.
Are we gonna have a semester test?
I usually have